Extension 1.6, Adding and Subtracting Fractions. In this extension lesson, you will use least common multiples to add and subtract fractions with unlike denominators. Example 1, adding fractions using a common denominator. Remember, we can add and subtract fractions with unlike denominators by writing equivalent fractions with a common denominator. One way to do this is by multiplying the numerator and the denominator of each fraction by the denominator of the other fraction. In other words, 5/8 plus 1/6. We could change that into 5/8 times this denominator, 6 over 6, because 6 over 6 is really just the same thing as 1, but it's getting us then to that common denominator, and 1/6 we can multiply by this denominator, 8 over 8, which again is just 1, so we can multiply by 1 without really changing the value. And that would give us then 5 times 6 is 30, and our denominator now is 48, 6 times 8, plus 1 times 8 is 8, and 6 times 8 is 48. So now we have the same denominator, and we can just go ahead and add the numerators. 30 plus 8 is 38, so we have 38 48ths. We could leave it like that, or we could try to simplify it to its lowest terms. I see an even number in both the 38 and the 48 in the ones place, so I know that I could divide both of those by 2, thinking back to my divisibility rules. 38 divided by 2 would give me 19, and 48 divided by 2 would give me 24. So that would be the answer in simplest forms. Again, I just divided the numerator and the denominator by 2. Again, since I'm dividing both by 2, I'm not changing the value, I'm just reducing it to its simplest form. The least common denominator of two or more fractions is the least common multiple of the denominators. The least common denominator is another method for adding and subtracting fractions that have unlike denominators. So in example 2, we have the same problem, find 5/8 plus 1/6. And this time we're asked to use the least common denominator to find that, which from the above description tells us that we need the least common multiple of the denominators. So the denominators are 5/8 the 8, and for 1/6 the 6. So multiples of 8 I'm going to start with. 8 times 1 is 8, 8 times 2 is 16, 8 times 3 is 24, 8 times 4 is 32, and I could go on and on and on indefinitely, multiplying 8 by the next whole number. I'm going to stop there and see if I get a match with 6, because I need the least common multiple. So as soon as I get one that matches, I'm done, and that's my least common multiple. So 6 times 1 is 6, 6 times 2 is 12, 6 times 3 is 18, 6 times 4 is 24, and there I have a match in 24. So 24 is the least common multiple. That will be my least common denominator for these two fractions. Now that I know that my least common denominator is 24, I can go back to my problem and say 5/8. I want this denominator to become a 24. In order to do that, when I multiplied 8 by 3, I got 24. So I'm going to multiply both the numerator and denominator by 3, which is really multiplying by 1 then, 3 over 3, so that I get 8 times 3 is 24 for my denominator, and 5 times 3 is 15 for my numerator. Doing the same thing with the 1/6, I know my denominator needs to be 24. And when I did the multiples for 6, I multiplied 1, 2, 3, 4, 6 times 4 in order to get there. So multiplying by 1 is 4 over 4 this time. 6 times 4 is 24, and 1 times 4 is 4. So 1/6 is the same as 4 over 24. Now I just need to add those two fractions together. I had 15 24ths plus 4 24ths. In adding fractions, I know I keep the denominator the same once they are alike. So the 24 stays, and 15 plus 4 is 19. 19 24ths, which is the same answer we got in example 1 after we simplified. Example 3, subtracting mixed numbers. Find 4 3/4 minus 2 3/10. They're asking us to do this using both methods. Method 1, the product of the denominators is the common denominator, and method 2, using the least common denominator. So starting with method 1, the first thing we have to do is get those mixed numbers into improper fractions. Recalling the procedure for that, you multiply the denominator by the whole number and then add the numerator. So 4 times 4 is 16, plus 3 more would be 17, 18, 19 fourths. And 2 times 10 is 20. Adding the 3 from the numerator is 23 tenths. So now we have the problem 19 fourths minus 23 tenths. In method 1, we're asked to use the product of the denominators. So my denominators are 4 and 10. That means that I'm going to multiply 19 fourths by 10 over 10 to get that denominator as 40. And the 23 tenths I'm going to multiply by 4 over 4, the other denominator, which is really the same as 1 again. So 4 times 10 is 40. 19 times 10 is 190. 10 times 4 is 40 again. That's our common denominator. And 23 times 4 is 92. Now I can do the subtraction because my denominators are alike. 190 minus 92 is 98. My answer becomes 98 40ths. Since these are both even numbers in the ones place, I know I can divide them both by 2 to reduce it a bit. That would give me 49 over 20. And then I would like to get that back into a mixed number. So in order to do that, how many 20s are in 49? There are 2. 2 times 20 is 40. And then I would have 9 left over. So 2 and 9 20ths would be my answer with that method. Using the least common denominator method tells me again I need to find the least common multiple of 4 and 10. So multiples of 4 would be 4 times 1 is 4, 4 times 2 is 8, 4 times 3 is 12, 4 times 4 is 16, 4 times 5 is 20, and my instincts tell me that I can stop there because when I do multiples of 10, 10 times 1 is 10, 10 times 2 is 20, and there are my two 20s. My least common multiple, my least common denominator, is 20. Going back now, I have 19 fourths was the mixed number that the improper fraction that I got from my mixed number. I want my denominator to be 20. In order to do that, I'm going to times by 5, both the numerator and the denominator, which is really 1. 4 times 5 is 20. 19 times 5 is 95. And doing the same with the other improper fraction of 23 tenths. To get to 20, I'm going to multiply by 2 over 2. 10 times 2 is 20. 23 times 2 is 46. So now I have 95 20ths and 46 20ths, and I'm going to subtract that. So I have 95 20ths minus 46 20ths. That's going to give me 49 20ths, which should look very familiar because we got that same answer over there, and it reduces to 2 and 9 20ths again. So again, this is proof that both methods work, and you just need to pick the one that works best for you.